My name is Msonda Alfred. Welcome to this YouTube channel, and I request you to subscribe if you have not done so. So today we are dealing with this physics question on the topic of electricity. As you can see, the first question is, in this lesson 1 under electricity, the first question is define the term current. What is current? So let's answer together. So in this case, we'll say that current is the flow of charge. Current is the flow of charge or electrons. Current is the flow of charge or electrons. Current is the flow of charge or electrons in a circuit. Okay, this is how we define. So current is the flow of charge or electrons in a circuit. Okay, so this charges carries energy. Okay, go on the second question now. Question B. So the question B reads as, calculate the charge flowing in a pressing iron using current of 4 amps in 3 seconds. So calculate the charge flowing in a pressing iron using current of 4 amps in 3 seconds. Let's calculate the charge. So the formula for calculating the charge is charge is equals to I current times time. So charge is equals to current times time. So in this case, Q stands for charge. Then I stands for current. Then in this case, we have got T stands for what? For time. T stands for time. So I have described the symbols which are used. So let's now finish calculating. Charge is equals to current times time. So in this case, what is our current? We have given our current, which is 4. So we take that 4, we write here. So 4 times, what's our time? Our time is given is 3 seconds. So we write 3 seconds. Then you say 4 times 3. What's the answer? So 4 times 3, the answer is 12. So the answer is 12 coulombs. The units for charge are coulombs. So the answer is 12 coulombs. I think you have seen what you have done. So now let's move now on to this question. This question is saying, figure 1.1 below shows a cell of 6.0 volt connected to the resistors. This is the diagram. So 6 volt, then we have got these 3 resistors. Okay, so the first question reads as follows. Calculate the effective resistance of the 4 ohm and the 3.6 ohm resistors. Let's now do this question. So here we are going to do it like this. We say we are calculating for 4 ohm and 6 ohm according to the question. So if you have seen 4 ohm, the 4 ohm and 6 ohm are in parallel. So here now we are going to answer like this. This is the formula the simplest formula we can use here is this one. Okay, of course there are 2 formulas that we can use, but let's use the simplest one. We are going to say total resistance is equals to, in this case, let's label this as our R1, then this as our 2. Then let's label this one as our R3. R3. Okay, we have labeled all of them. So I'm going to say RT, total resistance, is equals to R2, that one, times R3. So meaning that this times this over, again, over R2 plus R3. So at this point now, we can now substitute. So we are going to say, what is the value of R2? R2 is the 4 ohms. So we write down 4 times R3 is 6 ohm times 6 over. Again we say 4 plus 6. So in this case, 4 times 6, what's the answer? The answer is, this is, because 6 plus 6 will give us 12. So this is 24. 24 over 4 plus 6 is 10 over 10. Okay, this is equals to 10 into 24. It's entering there 2 times. 2 times. Then remainder, it's what? Remainder is 4. So 10 into 4, it can't. So we're going to write a decimal point. Then now we had a 0 there. So 10 into 40, the answer is what? 4. Then units are ohms. Then we underline. This is our answer. So for this question, we have calculated the effective resistance of the 4 ohm and 6 ohm. Okay. All right. Let's go on the next question now. Question B. Calculate the current passing in the cell. So what's the current now that is passing in the cell? So the current now is this one now. We are going to say, okay, current is equals to, but remember, we have got this diagram. Let me write this diagram for you. We have got this diagram. It's very helpful. So under this small diagram, we have got V is equals to IR. If you have seen, in this small diagram, we have got V over IR. So voltage is equals to, so in this case, when you are looking for current is equals to voltage over resistance. Again, if you are looking for resistance is equals to voltage over current. If you are looking for voltage is equals to current times R. Okay, so now current is equals to voltage over R, according to this, voltage over R. Then now we'll say the current, voltage, what's the voltage in this diagram given? The voltage is 6 volts. So we write down 6 volts over resistors. So now we are going to determine now the total resistors. So in this case, our circuit have changed. So it is now like this. You can see how the circuit have changed. Here we have got 2.6 ohms, and that is R1. Again here we have what? We have got 2.4 ohms, and this is R2,3. Okay, R2,3. Okay, so now in this case, we are going to calculate. We say total resistors is equals to R1 plus R2,3. So this is now RT, total resistance is equals to R1 is 2.6. So write down 2.6. 2.6 plus 2.6 plus there is 2.4. 2.4. What's the answer now there? So 2.6 plus 2.4, we are going to have this answer. So it's a 2.6 plus 2.4. So we are going to have 6 plus 4. The answer is The answer is what? The answer is 10. So we write 0, we carry 1. Then this plus this is 4. So plus 1, 5. So the answer now is 5.0. So in this case now here, our resistance is equals to 5.0 ohms. 5.0 ohms. Okay, so this is how we have calculated this, the total resistance, which is RT is equals to R1 plus R2, 3. Then we substitute 2.6 plus 2.4, which is equals to 5.0. So now, since we have now determined the total resistance in the circuit, we can now come back and substitute. So in this formula, we say current is equals to voltage over R. So voltage is 6 over current over resistance, which is 5.0. So we write 5.0 there. 5.0. Then we say this is equal to 5 into 6. It's 1. Remainder 1. 5 into 1, it can't. So we write a decimal point. Write a decimal point. And then we add a 0 there. Then we say 5.0 into 10. The answer now is 2. So we write 2. So the answer now becomes 1.2. 1.2 what? Amps. The units for current is amps. So at this level, we have been able to calculate the what? The current flowing in the cell. Now, let's come now to the other point where we're supposed now to find the power supplied by the battery. So, the power supplied by the battery. So, what formula can we use now in this case? So, the formula is this one. We are going to say power is equals to, in this case, power is equals to voltage times current. So power is equals to voltage times current. But mainly I would just write it, power is equals to VI. Power is equals to VI. So in this case, V, it's voltage. And the value for voltage is what? 6. So therefore, we're going to write that 6 times current. Current we have calculated, it's 1.2. Why? So 1.2 now, so let's write now 1.2. So 1.2. Then now we say this is equals to 6.6 times 1. Okay, then we do this. 6 times 2 is 12. So we write 2, we carry 1. Then now we say point. 6 times 1, it's what? It's 6. Plus that 1, it becomes 7. So the answer now is 7.2. What are the units for power? The units for power are watts. So we write capital letter W, or we just write watts like this. So the answer is 7.2 watts. That's our answer. So we need to underline our answer, our final answer. Okay, we have underlined our answer. So this is the question. So now we have been able to calculate the power. As you can see, this is how the answer looks like. Let's now come and do the last question over this part. So last question here is question D, which says calculate the energy converted by the resistors in 1 minute. So we're calculating energy now here. So now in this case, the formula for energy is energy is equals to power times time. Power times time. So power times time. That's the energy. So now, in this case, this is equals to what power are we calculated? Let's check. The power we've calculated is 7.2 watts. So now we're going to write it down here. We'll say power is equals to on power is now 7.2 times time now. Time is 1 minute. So 1 minute, we are going to convert this 1 minute. So I'm going to say in seconds, 1 minute is equals to 60 seconds. Then in this case, meaning that we are going to use this 60 seconds, because 1 minute is equals to 60 seconds. So we're going to use this what? 60 seconds. So now I'm going to light now 60 seconds E. So I light like this 60 seconds. Then now we say 7.2 times 60. 7.2 times 60. Let's try to use this paper. So I'm going to do like this. We say 7.2 times 60. Then we say 7.2, then write 60, 60. I'm sorry. So now we say 0 times 2, 0. 0 times 7, it's 0. Here we put 0. Then we say 7 times 2 is 12. So we write 2, we carry 1. Again we say 7 times 7, it will be 36, 37, 38, 39, 40, 41, 42. So 42 plus 1, 43. So now we had 0, 0. Then now we'll come and say plus 0 plus 0, 0. Here 2, here 3, here 4. So now decimal point, how many decimal points are here? It's just 1. So now the answer becomes 432. 432. So here the energy now is 432.0 joules. So this is the answer. So the question was calculate the energy converted by the resistors in 1 minute. So the answer is, the formula was energy is equals to power times time, which is equals to power is 7.2 times 60 seconds, because we are given 1 minute, so we converted 1 minute to seconds. So the final answer now is 432.0 joules. Thank you very much. See you in the next question.